Is it audible? Hello.
Yes, sir.
So good morning to one and all. Actually, in the last we have discussed the theory part of this one. Today we are going to do the practical for these two experiments here now. The measurement of power in three-phase circuit by two wattmeter methods for balanced load and unbalanced load. Both we are going to calculate here now. Actually, in the manual we have mentioned only balanced load, but practical we are going to perform for both balanced and unbalanced load. So the aim of the experiment is to measure the three-phase power using two wattmeter method for balanced load. That is experiment number 3. The experiment number 4 is to measure the three-phase power using two wattmeter method for unbalanced load. Okay. So according to the aim of that one, we required some three-phase balanced bank. Load bank is required. Wattmeters for the measurement of two wattmeters are required for the measurement of power, and moving iron instrument, that is voltmeters, are required here now. Two voltmeters are required. One ammeter is required. So actually VL will be same, but ammeters we are going to calculate here now. So for the balanced load, all the current current flowing through the all the load will be same only. For the unbalanced, it is required again. Three currents are required. Ammeters are required. So some connecting wires are required. So three-phase variac is nothing but variable power supply is required. So this is a circuit diagram. Yesterday also we have discussed this one. Yes. See here, RYB three-phase supply we are giving here now. RYB three-phase supply. The supply side we have given. Okay. And here one ammeter we have connected. Voltmeter we can connect, we can measure the voltmeter by between any phase here now. Line to line we can measure that one. See, RYB is there. So why we are taking as a common point here now? The pressure coil of the wattmeter we are connecting here of P1 and P2, both the wattmeter pressure coils we are connecting here. Okay. So then whenever we'll give the supply, this one, the wattmeter, it is going to measure the P1. The wattmeter 2, it is going to measure the P2 here. No, the summation of P1 plus P2 is equal to the total P1 plus P2 plus P3 we are going to get here. So V1, I1, V2, I2, V3, I3 we are going to get here now. So three-phase variable load, all the loads we are connecting here, same load we are giving here now. Same, the mechanical load we are applying to the all phases here now. This is same, this one same here now. The load is same. Then the balanced condition we are going to consider. If the R phase load is different, Y phase load is different, and B phase load is different, that is called unbalanced load. We are going to call that one. That is called unbalanced load. So according to that, the observation table we have to calculate here now. So from the circuit, actually deriving the three-phase power supply power for the star connection is root 3 VL IL cos phi here now. Root 3 VL IL cos phi. The line voltage, line current into the power factor here now, into root 3, that is total power we are going to get. So from the ammeter we can measure the IL. From the voltmeter we can measure the line voltage here now. Product of this into the power factor we are considering as unity power factor into root 3. Whatever the power it will give, that same power we are going to get from W1 plus W2 here. By doing W1 plus W2, we are going to get the same power we are going to get here now. So that is like that we have to take the readings here now. This total power should be equal to this total power here now. By using 2 wattmeter only, we have to measure the power here. So procedure according to that, we have to do the circuit diagram by applying the same loads, then measure the wattmeter 1, wattmeter 2 reading here. Make the connections as shown in the figure. The readings of W1 and W2 and V phase, I phase we have to note down in the observation table, then calculate the total power P using both the equations. WP equal to W1 plus W2 we have to do. Another one is P equal to root 3 V phase I phase, or root 3 VL IL cos phi also you can use. Cos phi equal to 1 means no need to consider here. So now write down this equal to this, we have to get that one. Why this many fluctuation is there today? Some people they are joining now. So theory part, yesterday only we have discussed it. According to the theory part, we have proved that one, the P equal to W1 plus W2, but instantaneous power equal to P1 V1 I1 plus V2 I2 plus V3 I3. We have proved that one. So same we are going to do here now. See, actually we are not going to do hardware here. This one we are going to do the virtual lab. I am going to conduct this experiment here now. Virtual lab, in the virtual lab I am going to conduct this experiment. Open the Google Chrome, all of you. Just listen carefully. This is the actual practical here now. So just type here the address that is called vlab.co.in here now. vlab.co.in here now. Just click on that one. You'll open the virtual labs website, which will be designed by a government of India, that is the Ministry of Education. There are this one virtual lab, an initiative of Ministry of Education under the National Mission of Education through ICT here now. Okay, so here home is there, about us. We can check the nodal op centers which are there, outreach and all the things you can check here now. And coming down, objectives will come here now. Some objectives of the virtual labs are there to provide the remote access to simulation based labs here, the simulation based labs, and to enthuse the students to conduct experiment. Due to this pandemic situation of COVID-19, your physical classes are not going on. For that reason, you can practice by using this virtual lab by sitting in your house, by using your computers or in your mobile also you'll try, but the internet connection should be high. Google Chrome you have to use in your mobile also. Broad areas of virtual lab you have to choose here. Broad areas means branches you have to choose: electronics and communication, computer science engineering, electrical engineering, mechanical engineering, chemical engineering, biotechnology, civil, physical, chemical. These many branches are there. Out of these many branches, which branch you are studying here? The branch you are studying electrical here now. In the electrical, you have to search first. You have to search the subject is there or not here. See here, virtual laboratory for simulation and gaming is there. High voltage lab is there. Substation automation is there. Sensors modeling is there. Virtual power lab is there. Industrial electric drives is there. Next, industrial automation is there. Machine is there. PLC, single board heater system labs are there. But there is no measurement subject here. The measurement subject is not there. So this is related to the measurement instruments are related to the electronics part. Actually, these instruments are related to the electronics part. So the electrical and another circuit branch you have to choose, that is electronics here. These are the common subject for the electrical and electronics actually. Okay, I will click on the electronics and communication now. See here, fading channels, advanced network technology, analog signals networks, and measurement lab here. Analog and network measurement lab. Just a minute. क्या बोल रहे? Okay. Pondering demo tech process to. कौन दी वो पार्टीशन दिया? ये कौन दी? पार्टीशन दिया वो। ये क्यों? क्या मालूम उसको? क्रॉस करना है ना? नहीं ये देखते तो तकलीफ हो जाती है। नहीं वो पार्टीशन नहीं किया, साइन करने की। ठीक। So analog signals and network measurement here. Measurement lab is there here. Analog signals network and measurement lab is there, which is designed by IIT Kharagpur here. This laboratory is designed by IIT Kharagpur here. I will click on this one. Just click on. By clicking on this one, it will take to that home page of that subject. Home page of that subject. You note down that one, vlab.co.in. Next, where you have to go, you have to broad areas, that is electronic and communication. Next, you have to go analog signals, networks, and measurement laboratory. We have to go that one here. So the internet connection is poor. For that reason, it is taking time to open that. See here now. Welcome to analog signals, network, and measurement virtual laboratory. This is the introduction here. Actually, three subjects are there. First one is basic electrical subject is there. Second one is signals and network laboratories are there. Third one is measurement laboratories are there. In the this one, 2 wattmeter method is comes under first year only. You have, I think you people are diploma student, but whatever the second year students are there regular, they were already studied this subject, that is three-phase AC circuits, that is star connection, delta connection in the first year only, basic subject. So this experiments comes under basic electrical and technology here now. And signals and network analysis subject will become for the second semester. It is also applicable here. No, the measurement laboratories which we are going to discuss, that is bridges, potentiometers, all will come under this. This is the introduction. Next, we will go for the list of experiment. Which, how many experiments are there here now? The screen is visible or not?
Yes, sir.
Analog signals, network, and measurement virtual laboratory. List of experiment is visible.
Yes, sir.
Okay, list of experiment, that is here three parts are there, that is basic electrical technology laboratory for UG students of all discipline they have mentioned here now, and signals and network laboratory and measurement laboratory here now. Actually this is belongs to you, measurement laboratories belongs to you. Which experiment we are going to do here now? Three-phase power measurement by 2 wattmeter for balanced load and unbalanced load here. Is there any experiment here? No. Measurement of capacitance is there, self-inductance is there, Kelvin bridge is there, self-inductance, Q-meter, capacitance, self-inductance. Only bridges are there here now. There we are not going to get here now. And some experiment they are doing here now to find the galvanometer constant, mutual inductance measurement by Campbell's bridge here now, precision resistance, mutual inductance measurement by Heider-Wheeler bridge here now. So you are not getting this experiment. It is there in the first year now, basic electrical here. Verifications of Norton theorem, Thevenin's, Teligans, superposition, million, three-phase power measurement. It is there here? Yes. You just click on this.
Yes, sir.
Three-phase power measurement. You have to click on three-phase power measurement. Again, it is taking time. So the internet speed should be high. Yesterday only I told, and once again I am telling that one. If the speed is more, then easily it will open. Very fast it will open. It is open now. Three-phase power measurement here now. Is it audible?
Yes, sir.
Okay. See here. The objective of this experiment is three-phase power measurement by 2 wattmeter method is there here. 2 wattmeter method. See here IL, I1 is there, here I2, I3, R, whatever the R phase they have used here now, IR, IB, and IY. Like that we are using here now. The current flowing through that IRN to the neutral here now. IBN, that is called B to neutral, and Y to neutral here now, YN. three currents are flowing here now. But if 3 wattmeters are there, but only 2 wattmeters we are using, means this IRY we have to consider, IBY we have to consider here. IBY we have to consider here now. So what do we have to do here now? So the connection diagram we have told, but mathematics to show the equations, they have given the error here now. See here, we are not considering this as a neutral point. We are not considering as a common point here now. Directly why we are going to consider as common point here now. According to that, the equations we have know that IRN VRN plus IBN plus VBN plus VYN plus IYN is nothing but yesterday whatever we have discussed, that is V1 I1, V2 I2, V3 I3 only. Yes.
Yes, sir.
So W1 plus W2 equal to V1 I1, V2 I2 plus V3 I3 only we have proved that one. Same equation we are going to derive here now by using only 2 wattmeters. Whatever the wattmeters are there here, this plus this, we are going to get the equations here now. We are going to get the output equations here now. Next we will go for the procedure here now. See here, for the balanced load different is there, unbalanced load, the procedure is different. Actually the unbalanced load circuit diagram has not loaded. I will refresh that one. Okay, see here. There are 2 experiments we are going to do here according to our syllabus. 2 different equations are there. Okay, 2 different equations are there here. Now for the balanced load, what is that? See here, the voltage, whatever the phase voltage is same, VL equal to V phase for the star connection in the 3-phase circuit. So only one voltage we have considered here. Now if the balanced load is there, the load applied to this load R and B, A, B, C, the load we have used, each phase is same, then current will also same over there. The current will also same over there. I1 equal to I2 equal to I3 only we are going to get here. But we have connected here W1 and W2 here. First what you have to do, connect the circuit as shown in the figure. As per this we have to do the connection. Next adjust the gang board of rheostat for maximum resistance here now. These are the rheostats are there. We have to keep this one as maximum resistance. Next, switch on the power supply. The button will be there. We have to switch on the power supply. Next, close the switch here now. Where is the S1 switch here? Here somewhere the S1 here now. This is the switch is there. The gang switch, we have to close this one. Read the meters to obtain line voltage. This is the line voltage. The current flowing through the phase 1 I1, I2 and I3. 3 wattmeters we are using. And note down the wattmeter reading of W1 plus W2. We have to note down that. Note multiplying factor in the wattmeter. What is the multiplying factor also? You have to add that one. Vary the load resistance and obtain at least 5 sets of observation. The current should not exceed the limit of 4.1 ampere here. Current should not limit the 4.1 ampere, the rated current. Yes. So the load current maximum we have to vary up to the 4.1 ampere only. So that is the load we have to adjust all the load. Ek resistance adjust kiya na, all the load resistance will be same here now. So that is called balanced load we are going to consider. This phase, this phase, this phase, same load we are going to apply here. Next, for the unbalanced condition, same we have to do the, see here, we have considered one voltage drop across this load here now, because this load is different. The resistance of this one will be different, this one will be different, this one will be different here. So already 3 wattmeters we are using. So V1 I1, V2 I2, V3 I3 will changes here. Because the resistance is changed, means the voltage will be changed, voltage drop across will be changes over there. For that reason, V1, V2, V3, we have to measure across the load here now. Same procedure, same circuit, only the load is same for all the phases, that is called balanced. If different loads we are using, that is called unbalanced, we are going to consider here now. What is the operating environment? A standard PC running Microsoft Windows XP or Windows Vista is required. Minimum 512 MB RAM is required. 500 MB hard disk is required, and the bigger screen is required. A mouse or other pointing devices, CD-ROM drive is required. So this is the procedure, and what is the requirement to run this simulation we have to identify here. Actually, I will go to the directly next. I will go to the procedure experiment only. I will go here now. Now I will click on the simulator here. This simulator, I will click on this one. See here. Here they will give. They have provided one link for that one. Link to the simulator. Once I click on this one, means it will take to the another window. It will take to the another window. It is going to take that one. It will take some time. Today the internet issue is there actually. I think first class also you have understood that. It's taking time to open because of internet problem is there in the college. So the simulation is opened here now. Simulation is opened here now. This is the circuit diagram. See here. The screen is visible.
Yes, sir.
I will take the spotlight here now. See here. This is the voltmeter we have connected here now. I have chosen this one as balanced load here now. This is for balanced load, and this one is for unbalanced load here now. Unbalanced load. Again, voltmeters here, some values we have, we'll get that one. That is voltage across this, and we are going to get here now. So first we will do for the balanced load here now. This is the balanced load circuit. Emitter 1, emitter 2 we have connected here now. The voltage we have considered here, and wattmeter 1, wattmeter 2 readings we have considered here now. See here. This is the load for the R load for the R phase, Y phase, and B phase here. So here what we will do, these values, they have given only one path here now. By varying this one, by varying this, we can change the load here now. मैंने एक load को change किया तो all change here now. Same load we are applying here now. Here 27 I will make that one. Again 28 here now. All 28 here now. So all three phase load is equal here now. For that reason, balance we are going to consider. R1 equal to R2 equal to R3 here. So the three phase load is equal here now. So balanced load we have applied here now. The balanced load we have applied here now. I will apply 20 here. I will apply 20 here. Set the three phase line. Next, here the switch is there. Here the emitter reading we are going to get, voltmeter reading, and downside it is going to display that one. The input voltage we have can provide here now. 100 volt, 200 we can provide here. See here. The set first step procedure, according to this procedure only we have to follow here now. And the downside, they have given the observation table also here. See serial number 1, 2, 3. How many readings we can take that one here now. The line voltage here now. So phase current 1 and power factor here now. Cos they have given here now. Next VBY, voltage between B to Y, R to Y and B to Y here now. And IV current here now. And angle between power factor of this Y to B here now. And I3 here now. I3 ampere, the current flowing through this one here now. And W1, W2, here calculated value it will give, and here measured value it is going to give. Whatever the observation table I have shown here, same table it is going to show here now. Calculated value, measured value it is going to display here. All of you sit with calculator. Set the three-phase line to line voltage to 100 volt at frequency 50 hertz. They have given as 100 volt. I can increase that one into 150 or 120 also. We can take that one. How much? Anything you can take that one. I will take 120. 120 I have taken here now. The frequency is 50 hertz only. Set the balanced load value here now. How much can I set? 20 only. 20. Can I set 20? 25. Okay. 25 ohm. I will set that one. Next, switch on the supply to get the meter here now. Here the button is there. I'll click on that one. Click on it is. The button is switched on. Yes or no? Values here displaying here now. The voltage, how much you have given input? 120. So the line voltage is 120 here now. The current is, it is 2.7 is there. 2.77 they have displayed here now. It's the same current because the balanced load is there. Current is same only here now. 2.77, 2.77 here. So the 287.731 is the wattmeter 1 reading. 288.296 is the wattmeter 2 readings here. Wattmeter 2 readings. The load 25 we have given here. The load 25 we have given here. Can I fill the table now? These all values I can enter into the table में enter करूँ? Yes?
Yes, sir.
Yes, sir.
Can I enter that one? Otherwise, we can calculate this one. VI cos pi only, na? This conversion, that one. Directly it will calculate here only. I will fill that one here. See here. 120, 2.77, 0.86 is the cos phi value here now. 0.866. And W1 equal to 287. W2 equal to 288. Calculated value is 575. And the derived value here, measured value is 576. 575.99, 576.03. It is same only. Yes?
Sir.
Is it same or different? Is it same or different? I'm asking to you people only. 120 into 2.77 into 0.86 3. $498, 577 here now. Just a minute. 2 point. See here. The cos phi we can consider as 1 here. That is detecting here. But according to that, the formula is, we know the formula is √3 V1 I1 cos phi. Yes or no?
Yes,
Okay.
sir.
Yes.
I will enter √3, you enter here now, into 120, you do into 120, into what is the current here now, 2.77, 2.773, I will enter here now. See here, 576 we get here now. Is it visible or not?
Yes, sir.
576. Same, the calculated you have got here 575.999. The measured value is 576. We can take the different reading again. Here, once we fill the table means it will erase all the data here. Next, what I will do, instead of 30 to 25, I will give 30 here now. The load I will change here now. I will switch on the supply again. See here. Here 239 is there, 240 is there. So again the reading is changed here now. Here 120 only, but the current value is changed. 2.309 it came. Yes. 2.30 came it is. So calculate the value of power now. Any one of you, if you have the calculator, you calculate it. √3 into 120 into 2.30939. How much it is?
$479.99.
479.99. So then 479.99 means 480 approximately. Yes. 239.7 plus 240.247. You calculate here now. How much it is? These two. W1 plus W2, how much? Both are equal or not? It is also 479.9 W1 plus W2. Yes. 239.7 plus 240. 239 plus 240 कितना हो गया? 279. 0.7 plus 0.2. It is nothing but 239.9 only. So 479.9 only. So both the answers are satisfied here. No, both are equal. So again, I will fill the table here. I will fill the table. See here. Please switch on the supply. Okay. I have filled the table here now. 479.998 and 480.05. Measured value. This is calculated value. Next, what I will do, I will give 40 here now. Instead of 30, I'll give 40 and I will switch on the supply. Again, you calculate here now 180 plus 179. 180 plus 180 here now. 360 we have to get here now. 120 into 1.7 into root 3. That is called also 360 only we are going to get. Again, you fill here now. 59.98, 360 here. You can check the current here. The current value also you have to check here now. How the load is increasing, like that the current is decreasing here. Yes or no? So what I will do, instead of 40, yes, I will give just 5. I will give here now. The load resistance I will give 5 here now. I will switch on the supply. See here. Click on the fuse indicator. Okay, it is not taking 25, minimum 20 it is taking here. So 15 ampere I will, no, already it has taken. Switch it on, it is. Instead of 25, I will take 15 here now. I will take 15 ohm and I will switch on the supply. See here, 4.6. What is the rated here now? 4.1 से आगे नहीं जाना था. Yes or no? So it is going to damage the circuit over there. For that reason, minimum 20 they have taken here now. Minimum 20 they have taken. So instead of this, what I will do, I will take another one. For how much we have taken? 40. Na? I will take 50 ohm now. I will take 50 ohm. I will switch on the supply. Calculate here 144 plus 143 means 288 here now. 288 we are going to get. It is that 288. 287.99 here. So next to give the value of 60 here and switch on the supply. The last fifth reading it is 240 here. See here how the load resistance is increasing, the total power is decreasing here now. Yes, the current is decreasing, so the power is decreasing here. So this is the calculated value and measured value. Both are matching or not here now? The three-phase power we have measured by using 2 wattmeter method, and calculated value and measured value both are similar here now. Can conclude this experiment. The three-phase power only we are measuring by using how many wattmeters?
2 wattmeters.
2 wattmeters only here now. So calculated value and measured value both are matching. So by using 2 wattmeter also we can calculate the three-phase power correctly here now. That is for the balanced load. Next we will go for the unbalanced load. For the unbalanced load, this load is different, this one is different, this one is different. Different we have to add here now. So any doubts here for the balanced load?
No, sir.
Okay. Next I will display the unbalanced load here now. See here the unbalanced load I have displayed here. Here also only 2 wattmeters only we are using, wattmeter 1 and wattmeter 2 here. So the line voltage we have considered here now. So and the voltage drop across load 1, voltage drop across load 2, and voltage drop across load 3 here now. This one we have to measure here. This is phase 1 voltage, phase 2 voltage, phase 3 voltage here now. We have to measure. This is line voltage. This is V phase we are going to use. V phase, V phase, V phase here. The I phase equal to IL for all the loads here. See here for the load 1. They have written 120. I will write 125 here now. 125, 155, and 170 I will use here. Yes, all the loads are different. This is 125 is there, 155 is there, 170 is there. Loads are different. Yes.
Yes, sir.
So the input voltage I will give 100 volt only. The line to line voltage, this is R to Y and Y to B here now. And frequency I have given 150 hertz. Okay. Set the frequency and set the load resistance I have set it here now. Can I switch on the supply now?
Yes, sir.
I'll switch on the supply. See here now. See here. The current is 0.86 here now. 0.65, 0.5 here. The phase current I is different here now. The current is changed from the each phase here. You calculate here now. W1 plus W2, you do that one. How much it is? Nothing but 110, 220 it is. Yes?
Yes, sir.
So this one, V1 I1 is different plus V2 I2 plus V3 I3. By doing that one, all the equations we are going to get same here now. 107 into 0.86, 91 into 0.5 plus 111 into 0.6 here. Now we are going to get 210 only. V1 I1 plus V2 I2 plus V3 I3. Yes, that one only we have to prove. Na?
Yes, sir.
VR, Vy plus Vb and IR, IY, IB. We have calculated here now. See, 107 plus 556 into that is 0.86, 045 plus, just a minute, oh, change okay, 107. I will take the open bracket, 107.556 into 0.86 plus, that is second one is 91.445. Now we have to take bracket na 91.445 into 0.58997. Oh, close bracket plus 111.475 into 0.655. It is nothing but 219. How much it is? Nothing but 219.46 away. So anyone you calculate that one, what 111.79 plus 109.49. How much it is?
220.
220 and 219.9 both are same only. So calculated value and measured value both are same only. I will fill the table now here to check here now. So the calculated value is 219.59 and the measured value is 221 here now. There is less error is there. Similar answer we got here now. So with point they have considered some 4 digits of point. By considering only 2 digits of point, we will generate is this value also. Both are similar only here.
Yes, sir.
Yes. Next I will what I will do. This one 125 I have taken. I will take this one as 155 now. 155. I will change this one as 130. 130 I will change that one. The load is changing now. Again, this one I will change as 160 here. It's just okay. 160 here now. See here. All the loads are changed here now. Now I will switch on the supply. See here 121, 119 again. I will fill the table here now. Once again, I will fill the table. This is 238, 240, 238.6. Some error is there, that is called the difference we are going to get. That is 1.5. We are going to get the difference here. 1.5 we are getting here, the difference here. 1.5 we are getting the difference. Next, what I will do, instead of this 160, 180, I will change this one into 200 directly. I will change into 200. This one I will change into 180 here now. 180. So all are 30 differences there. Again, I will switch on the supply. See here, I will switch on the supply. What is the answer? That is 0 we got, no? So off here now. See here, 93, 91, the answer we got here now. I will fill the table again. See here, 185 we got here and 183.4 we got the unbalanced condition here now. Next, what I will do, I will change this one into directly only one load. I will change that one, that is called 220. I will do that one. I can switch on the supply here now. I'll switch on the supply. and I will fill the table. See here, 164. So instead of increasing, I will decrease this load here. No, I will give only 20 load here. No, see this much difference, 20, 180, 220. Then also I'll get the answer same only. I'll fill the table last one here. No, see here, 233.8, 235.5 here. So for the unbalanced condition, actually is here, unbalanced load, we have not given any circuit diagram and we have not given any observation table in the lab manual. You note this observation table. You can take the circuit diagram and this observation table and procedure. You have to write this one only here. All the things you have to write same as it is in the write-up part, lab write-up part. It is which is going to help for your term work marks. For the term work marks, it is going to help over there. So this is the circuit diagram and observation table. We have to do like this. V1, V2, V3 also you can write down. VR, VY, VB also, and I1, I2, I3 or V1, IR, IY, IB also. Phase voltage, phase current, you can do that one. Okay, any doubts?
No, sir.
So for the unbalanced condition, the V1 is different, V2 is different, V3 is different. For the balanced condition, both are same only we are going to get. Okay. For the current is also different we are going to get for the unbalanced load, because each load is different only we are going to consider here. So it completes the experiment number 3 and 4. Already 2 experiments are over, na? Yes.
Yes, sir.
So it completes experiment number 3, that is called 3-phase power measurement by using 2 wattmeter method for balanced load. For the balanced load, that is experiment number 3. This is balanced load, and we can take the screenshot of this one also. I'll shift this one into where I have to save it. I'll minimize this video also. Okay. See here, for the balanced load, we can take the circuit diagram, procedure, and observation table. Okay, based on this one we have to write for the balanced load. Next, for the unbalanced load, we can draw this circuit diagram and this observation table you have to write in the write-up part here. So you can practice this one by, if you have a computer, laptop, or in your try in mobile also, but it is very difficult by using mobile also. By using your mobile, it is very difficult to complete this task. Means it will not open in the computer itself. It is taking this much time, so it will not open. I will ask randomly. Rule number 15, Vaishnavi.
Yes, sir.
Have you completed the write-up of experiment number 1 and 2?
Sir.
Your voice is not audible, madam. Speak loudly. Yes or no? Leave that one. Voice is not clear. Amit Jadhav, 22. Jadhav Amit. Amit Jadhav, unmute and speak out. Roll number 22. 23. Roll number 23. 25. Khandekar. Ravi Khandekar.
Sir.
Have you completed the write-up of experiment number 1 and 2?
No, sir.
Why? When you will complete then? See, for direct second year students, it is very difficult to complete all the write-up. Today's work we have to finish today only. See, for the EMI, already 4 experiments are over. Today you consider means 4 experiments will get over. So another 4 experiment I can finish in 2 to 3 lab. I will finish that one. So you have to upload that write up in the whatever the link we will provide. That one we will verify, that one we will check that one, and based on that we are going to give the term work for you peoples. Your term work policy, it is completely depends on your lab write up, your class attendance, lab attendance, and ISC and chapter test. I don't know how many of you have you were absent for the first chapter test. You have to give the chapter test compulsory, especially for the direct second year students. Will get the less time to complete. So today's work only you complete today only. Don't be lagging for the writing work. Okay, any doubts?
No, sir.
Will you complete today itself this write up parts? So instead of writing the manual write up, manual procedure, instead of writing that one, you write this procedure only. Manual में जैसा है ऐसा मत लिखो, ये this procedure you write down. All of you take the screenshot. This unbalanced load का है ना, balanced I will display this one. For the balanced, this procedure, this circuit diagram you write down. Instead of this voltmeter ऐसा diagram नहीं लिखने का, सिर्फ V बोल के circle में V लिखने का, और इसको ammeter already it is there here now. For the balanced load, you write this procedure. For the unbalanced load also, you write this procedure here. I have chosen unbalanced load now. This procedure you write down. And the readings also, you have to take the screenshot of this one. You have to enter here. Okay. Is it clear? I am in bank, so I can't unmute myself. Okay. All of you, you know the procedure, how to open the vlab.co.in. Then you go to the broad areas that is called electronics and telecommunication. In that one, we have to choose network theorems and network, which is analog circuits, network and measurement lab. In that one, you have to open for the list of experiment. From the list of experiment, basic electrical engineering in that subject, you have to choose the 3-phase power measurement. From this one, you are going to simulation. You have to click on that. The simulation will open here. Now, this is the procedure of this experiment here. Now, you are going to get here. So, if you don't have any doubts, then I will close. Just a minute. I will ask the roll numbers who were present, who all are not present. Check that one. Roll number 1 is present. Roll number 2 present. Roll number 5, 5, 6, 7, 8, 9, 10, 11, 17, 19, 20.
20 present, sir.
Okay. 20, 21, 22, 23, 24, 25, 26 is present. 27, 29, 31, 34, 35 is present. 36, 37.
Hello?
Yes.
33 is present, sir.
33 present, I take.
36, sir. 26.
36 present, 26 absent. Okay.
26.
Okay, present.
Sir,
Sir,
20
20
present. 20 present, sir.
ठीक है 20 present है.
Sir, 26.
26 present है, 36, 37 absent है.
सबको लाइन में ले लो.
कौन है?
आपका ग्रुप का.
ठीक है. We'll end here only.